Hello friends, welcome to k8s YouTube channel. Friends, in today's video, we are going to start a complete Kubernetes zero to hero course. So this will be gonna to our first video. From here, we will start our journey to mastering the Kubernetes from absolute beginner zero to expert level journey. Okay, so here let's start with our first video. Okay, so let me start my PPT. Okay, so let first I will introduce to myself. My name is Saurabh Singh. Okay, so here my channel name is k8s. You already know that. So I am working as a technical lead for a big MNC, and I have done the degree like BCA, MCA, and also some certification like RSCSA, RSC, AWS CSA, SA, and also Microsoft Certified Azure Administrator, and many more. Okay, so let's begin. So agenda of this video will be like the problem statement, the why we need Kubernetes, and we will then introduce to Kubernetes, and what is the difference between monolith and microservices, what are the virtual machines, and what are the containers, and we will then define the orchestration and the architecture here for control plane and worker nodes. Okay, and also we will go into deep for control planes internals and worker node internals, and we will cover the very important concepts like pods, replica sets, deployment, services, networking, config, secrets, and storage parts of Kubernetes. So this we are going to cover in next 30 minutes. Okay, so stay tuned with this video. Okay, so the evolution of deployment, first of all, like in traditionally we are basically installing the operating system on our servers, directly on our server. Okay, so there will be some bare metal hardware like server by some OEMs like HP, Lenovo, IBM, Dell. Then directly we are installing the enterprise operating system over that like RHCL or Windows Server or any other your choice, as per your choice. Okay, so after that we are deploying the application over that. So that was the very hard to scale and also very hard to maintain. Okay, like we have to maintain the high availability, we have to maintain the scalability, we have to maintain the operationability, we have to maintain the cost efficiency. Okay, so that was difficult. So that after some time the era of virtualization has come. Okay, so there we first on bare metal hardware we deploy first hypervisor, then after that we create the VM over that. Okay, like in that, if you talk about that, then on bare metal hardware of any OEM, we will deploy like VMware ESXi, and we centrally managed by using the vCenters like tool. Okay, so VM gave the isolations like here. If you know the concept of VM, if you don't know the concept of VM, then you can see my previous videos. Okay, what is the VM? How we can create a VM? Okay, so it's basically isolated the environment. It has created the different machines, okay, virtual machines you can say on the same hardware, but it was still very heavy. Okay, so now that is the containers era. So here what we do, it's basically we virtualize the operating system. So here we get the shared kernel, and over that our container engine run, and we deploy the application over that. Okay, that is very agile and lightweight. Okay, and also very easier to maintain, like as per concept of high availability. If we have to maintain scalability, we have to also operationability and cost efficiency. Okay, so first we need to understand what was the monolith. Okay, so like previously we are using the monolith based software. Okay, so monolith is software pattern where all components, basically UI, business logic, and database access, all are packaged into a single executable or deployable file. Okay, everything is tightly coupled. If you change one line of code, then you have to or like in payment section, then you must to recompile and redeploy the entire application. Like if you take the example of this type of application, then this type of application you can think about the old versions of Finacle, old versions of Oracle, financial services, analytical applications. Over that, like there are multiple types of applications. Like previously, we are mostly working with the monolith softwares. Okay, so its only pros was it's simple to develop initially. Okay, but later it's became too complex. But cons are like single point of failure and scaling. Like if you want to change in one component, then you have to change completely redeploy that. Also, we require it's required like if you have to scale that, then it was also very costly. Okay, also very so result is like very slow deployment life cycle. Okay, so in the fast pace of business, like here our business are changing very fast in nature. Okay, so it's very agile. Okay, so first problem was with monolith was that was very common was it works in my machine, not on peer machine. Why? Because the complete environment of operating systems or environment variables has changed. Okay, so that's why it may work in my system but not work in my peer or my colleague system or on servers also, like or in different environments, like inconsistent environment, like between development, test and production. Like it was working in development but not working in test or production system. Okay, so that was the main like problem for the as per developer perspective. Also, there was problem with monolith with as per operational perspective that I told you. Like it was very complex to maintain, update. Okay, by maintaining the high availability, scalability, and also the cost efficiency. Okay, so here it's a basically what is microservice. It's a basically here we break our complete application or software into small independent portable cross-platform services. Like we deployed separate Microsoft service for login, for payment, for search, for logic, for APIs, and all. If you are taking example of any finance, any e-commerce application or financial application, like these are the common module. This login. Okay, so if you are going for any enterprise software. Okay, so benefit was like independent executable was there. Like we can change in our login and we don't need to redeploy the payment, search or logic microservices. We just need to recompile the login if you want to change in login, and this was also scalable. And also it's have technology flexibility, like we can independently upgrade to any of the microservice application microservice. Oh, and also there was the fault isolation. Okay, so the now we have the microservices based applications. Now for running that, we have the as a solution we have the container. Okay, so what is container? So it's basically you can freeze the complete entire environment of OS. Okay, so you can freeze complete entire environment for microservice into an image. Okay, whether it's run on your laptop or on your friend's laptop or an AWS VM or inside a Azure VM or in your local RHEL server, it behaves exactly the same because it carries its own word with it. Okay, because it's already have their OS environment, executables, everything, and application too with there. Okay, so now what major channel challenge comes when like we already make a big application into multiple small independent portable cross platforms, small microservices. Okay, so also we are going to deploy mostly microservices inside the containers. Okay, so it means we have very huge amount of containers. Okay, so like hundreds of these small microservices running inside containers. It means if you have hundreds of microservices, then we have we are going to deploy hundreds of containers too. Okay, so it increases the complexity also, like management complexity. Okay, so for solving this complexity, we have Kubernetes. Okay, that is the basically orchestration platform or management platform. You can say containers management platform. So let's discuss a few more points for containers versus virtual machines too. Like here in virtual machines we have hardware level of isolations, whereas in containers we have OS level of isolation. Okay, like here virtual machines are guest OS per VM, and here it shares host kernels itself. Okay, its size in GBs and container size maybe in MB also, maybe in sometimes GB. Okay, boot times, it's virtual machines boot times in minutes, it's containers boot time is seconds. Okay, so here let's begin with the Kubernetes. What is Kubernetes? As I told you, it's a open source orchestration engine or platform that automates the deployment, scaling, and management of containerized applications. Okay, so if you think like a container, like it may be based on Docker, Cryo, okay, or containering. So it's a single musician. Then Kubernetes is the conductor, ensuring the entire orchestra plays in harmony. Okay, it's basically originally built by the Google. Okay, based on their 15 years of research and development, they are already running their internally. They are running the board application, so they learned very deeply on that, and they have originally created the Kubernetes, and later they have donated it to the CNCF. Okay, now it's maintained by the CNCF Cloud Native Foundation. Okay, so why Kubernetes? So like if we not use the Kubernetes, then what the challenges we can face? Like we have to scale manually. We have to solve the system crashes from onset. We have maybe some downtimes during the updates due to the failures, and during the update we may waste hardwares because it's not possible every time. Like we will go and find like where there is a space, then we will create the VM. Okay, it's also like create a service discovery problem. So all problems we can easily resolve by using the Kubernetes. It's auto scaling. It can automatically adds remove container based on CPU RAM usage. It can self-heal, like restart failed containers and replace dead nodes instantly. It's rolling updates, swap old versions of new ones with zero downtime, and bin packing efficiently fix container onto servers to save cost. It's also load balances automatically, gives you wrap and IP and balance the traffic. So if we go to the architecture of Kubernetes, then it's mainly three things. The user CLI, like here mainly we use kubectl. Okay, so you can think about like a customer ordering a pizza. Okay, like control plane is the brain or master. So you can think like the kitchen manager or order system. Okay, that is actually managing everything behind the scene, and then you can think about like here worker nodes, the brain or servers where actually work will be processed or done, like you can think the pizza oven or delivery stuff and delivery stuff. Okay, so these are the main three components, like the user CLI, control plane, worker nodes. Okay, inside that, if we go deep, like this is the complete architecture. You can think that first one is the control plane, second one is the worker node, and here you can use the kubectl, okay, by using, or you can use webui2. Okay, so it's basically when you request, like when you go the kubectl command, then its request directly goes by using https API calls to kube API server. Okay, and then kube API server transfers those requests based on their nature, their type, and many other variables. They do the task, okay, and they perform the task where they perform the task on worker nodes. So if you talk about the main components of master node, then there is a kube controller manager. It's basically regulates the complete cluster state, and then kube API server, which one is the central gateway. Like every request you are doing is go to the kube API server first. Okay, then it very integrally communicate with the etcd, that is the basically a kube value store. You can think about the it's a complete internal database for the complete Kubernetes cluster. Okay, so it's then main component is kube scheduler, which basically assigns pods. Okay, here you can think there is a kube controller, one more kube controller manager. It's basically here you can think it's like for it's a work like the cloud controller manager. It means nowadays if you deploy our Kubernetes cluster inside any cloud platform like EKS, okay, so then there will be a separate cloud manager, cloud controller manager will be there that directly communicate with the cloud providers API. Okay, so it's a part of basically control plane. Logically it's part of control plane, but when you see in real case, it's basically run in the either on separate pod, okay, either very strongly connected with control plane. Okay, so here it's it's attached with net by using the network CNI interface with worker nodes. Like there might be multiple worker nodes and also multiple control plane. For availability architecture, we must require the at least 3 master or control plane nodes. Okay, and also at least 2 or 3 worker nodes for high availability architecture. But this is just an introduction. So here, like if we talk about the main components of worker nodes, then there will be the kubelet agent, kube proxy server. So kubelet is the first agent, which basically when we kubelet receive the commands from the controller plane, okay, either you can say from master node directly, and they convey to pods. Okay, and kube proxy is basically for networking, like it assign it's manage all the tasks inside the node that are related to networking, like where traffic will go, what are the rule there, okay, like all. Then it's connect to pods. Basically pod can run one container or multiple containers, okay, inside a single node. Okay, so these are the main components. You can think that you can just make a quick idea about that. Also there are some services that basically communicate with all these. Okay, and also for storage we use the persistent storage. We can use persistent storage because pods are ephemeral in nature, they can die anytime. Okay, so if you just stick with the storage part, then your data may loss. Okay, so that's why here also very good concept of persistent storage, so that your data should not be lost at any cost. Okay, so this that I already explained, like kube API server, gateway to the cluster, etcd, it's a distributed kube value store database. Okay, kube scheduler, it's basically assign pods to node, like which pod will run on which pod or which node. And kube controller manager basically managed controllers, replica nodes, endpoints. There was two control manager. One task was like communicating with the cloud APIs. Okay, so let's deep dive into the internal of the control planes. Okay, so if we like go inside the control plane, then there are also multiple components inside the, because it's a brain, so you can think about, you are understanding a brain of something, then it's a very complex part, because brain is the understanding, brain is the only way to understand that person. Okay, so like here, if we have to understand the Kubernetes, then we have to understand the brain in very deep manner. Okay, so here like it has already I told you, it's an API server, it is as a database, scheduler, controller manager. So wow, how what are the things they manage? Like they manage rollback access control, like who is authorized to do what task. They also do the node authorizations, like is this node is authorized node or not, if we can admit this as a worker or as a master node. We can mutate webhooks, or it's also responsible for validating the webhooks. Okay, so basically all these things will done by this. And also if we are like running the high availability cluster database, then there might be some more than one control node, so that there might be multiple etcd databases and multiple these all things. So it's basically communicate with very low latency network. Okay, so key data types here it's supported is like config maps, secrets, endpoints, cluster status, and multiple things. Okay, and all these things. So here, like if you have to manage all these things, then basically what we can do, we can take the, also in enterprise we take the backups of these, okay, control planes, because if we lost our control plane, then complete cluster will destroy. Okay, so it's very critical to take the backups of this, and also monitor this by using the like Prometheus, Grafana, or any other tools that you can just define that, like what tools you are going to use that for the same purpose. And also like high availability logic, you have to maintain that. Like when we talk about the controller manager, then there is like node controller, replication controller, endpoint controller, and deployment controllers. Okay, so like what is deployment controller? Like when we deploy, then what are the specification there mentioned, and how many we have to create the replica of that pod. Okay, and where we have to create that, all things are basically defined by that. And scheduler define like when, at what time, which node had to select. Okay, so it's basically does the run the some algorithms, okay, to define the least requested nodes, balanced resources, to check the resources, like what is the current resource utilization there, and we can schedule the pod creation on that node or not. Like all these things is calculated by using these algorithms that basically schedulers run. Okay, also there is like internal load balancer for etcd endpoints. Okay, so that all the traffic goes in balanced way. Let's go into the worker node internals. Like every worker node has a kubelet that ensures pods should be running as per the specification given by the master. Okay, and there is also a kube proxy that manages the networking, and it also ensures that as per the instruction of the master, all networking components should work as expected. Okay, and container runtimes is basically provide the executable environment to the containers. Okay, so if you talk about pods, what is pods? So it's a basically smallest deployable unit. You can think a pods can have multiple containers. Okay, can run multiple containers, but this is generally preferred way to run a single container inside single pod. Okay, let me give into the diagram. Like here, this is the host server. Then on this host server, we have a pod. Okay, and inside that pod we can have multiple containers. I told you, like the main container may be the your Nginx web server that has applications codes and listening and port 80, and there may be some sidecar containers that might collect log. They might initiate the environment for your Nginx. Okay, like there may be some initialization containers also. Okay, here inside the pods we have pod namespaces that are basically a combination of process, network and mount isolation. We can have shared volumes or persistent volumes here. So all these things are happen inside the pods. Okay, so how it is unique IP is given to pod. Here you can just think about the nodes queue proxy. That first let's go to understand about the we understand the pods. Now how these things comes here. Okay, who decide? Like the instruction comes from master. Okay, then here it's come to the API server. Okay, like you can think about like it's come to first here. Okay, then here kubelet will done these things, like kubelet agent is running on every node. You already know that, and that kubelet responsibility to ensure the state match to pod specification that is already given by the master. Okay, so it's maintain the life cycle, health checks, log, etc. Also it's provide the container runtime, like it may be cryo based, docker d, container d based or docker based. Okay, so it's provide the runtime for running the Kubernetes pod. Okay, so now here also node storage, like it will have some compute resources will be there, some memory resources will be there, and some storage. Okay, so this is the complete idea of this. Now we'll understand what is the replica. Like here ensure what is the purpose of replica sets. So purpose of replica sets is to ensure the specified number of pod replica should be run on the nodes. Okay, like here we take example of Nginx. So this is the just a single replica here. But if we have multiple nodes, then we can create the multiple replica of same. Like if you have to create the 3 replica, if you want to make fault tolerance and highly available, then we will require at least 2 or 3 nodes here. Okay, to run that. Otherwise it can create replica on same nodes also, but it will be not highly available because your node will get down and your all pods get shut down. Okay, so we have to ensure that these are things. Okay, like what is the deployments? Its purpose is basically to create a declarative documents. Okay, so that will basically updates to replica sets and pods, or create the replica sets and pods. Okay, so it will be very useful or during the rolling updates. Okay, what are the services and networking? Like services are basically responsible for, these are the main components you can understand, like how your containers 1 will communicate with container 2, how your node 1 container 1 will communicate with node 2 container B or container 2. Okay, so these all things will be defined by the services. Okay, Like you can think about the like cluster IP as per for internal communication, node port for exposing services on node IPs, and load balancer for external or internal access. Like load balancer can be used for both, but mostly in the terms here we use it for external access. Then there is also concept of config map and secrets. Config maps you can think about store non-sensitive configurations, okay, and secrets is basically store the sensitive data like password tokens. Also we need to secure these secrets too, because it's not just name of secrets, because it's encoded in base 64. Okay, so we need to also encrypt these secrets one more layer. Okay, so like this is the most important concept. Like data is the most critical thing in any enterprise. Okay, so we will require the persistent volume there. We will require some persistent volume claims, so that our container or pod can use that persistent volume, and we can have storage classes where we define the different type of storage. That might be like some fast based on their accessibility and their IOPS speed. Okay, we will also take the example of dynamic provisioning in our next video. Okay, so like here if I will show some demo commands here so that you can understand that. So here I will use the PowerShell, although you can use the command line, but it's always good to go with the PowerShell. So here I have already installed the Minikube. Okay, I will also upload this video how you can easily install the Minikube on the Windows 11 or any Windows based system. Okay, so let me check the Minikube status. So it's saying all is stopped. So we will start the Minikube cluster. Okay, it's hardly take 13 seconds. So what is Minikube? If you don't know Minikube, then I will like Minikube is just a very small version of Kubernetes. Here all the things like master and worker nodes will run on the same node inside a VM. Okay, so here it's starting Minikube. Okay, let me here check the Minikube status. Okay, so it's now running and kubeconfig is configured. It means you can use the kubectl command. So here you can use the command like kubectl get nodes. So it's saying it's a type name is Minikube, status is ready, roles is control plane, and age is 12 hours. Okay, so we can also like give the command kubectl gets services. So it will show you what is the services you have configured. Currently its name is Kubernetes and type is cluster IP, and cluster IP is this. Okay, so we are going to see in next video how we can easily install the Minikube. Also we will go to see how we can install the 3-node full high availability cluster in next video. That video is actually already uploaded. I will put the link in the same playlist. Okay, so that you can get the deeper concept how you can just exactly create the high availability Kubernetes cluster. Okay, so this is the Minikube. Okay, and now here you can run any command. Okay, so we'll go into deep in next video. Like here it will execute this command. Sorry, describe. Okay, we have to mention here like it's a node, so we have to mention that. Okay, so all the information you can see that. Okay, so here we are ready to go with our practical videos. Okay, so this video is completely theoretical, but next video will be completely hands-on video. Okay, so stay tuned with us. thanks for watching this video. Hit subscribe button. Okay.